Hey guys, today we're going to talk about an approach to hemolytic anemia from an investigation perspective. So, when it comes to hemolytic anemias, what are the investigations that are suggestive of that? That's going to be your low hemoglobin, increased retic count. So, why is that? Because body is trying to compensate by making more cells, and of course the products of red blood cell breakdown. Now what would this be? So it would be hemoglobin and then hemoglobin, and then heme part would further be broken down, and ultimately your indirect bilirubins would be more, and then LDH, which is an enzyme that is inside the red blood cells, that would be more as well. Also, other contributing factor for LDH could be anemia causing hyperperfusion or hypoxic injury, and then that could give rise to LDH as well, but mostly because LDH is released from broken red blood cells. And when the end product heme is transported around the body from the guy called haptoglobulin, right? So when the heme is more is bound to haptoglobulin, so the haptoglobulin levels would be less. And also it is important to note that haptoglobulin would be significantly reduced in intravascular hemolysis compared to extravascular hemolysis. So purely from an investigation perspective, the most useful test to do first is that you do a DAT test, or like an antibody test, right? So you do the DAT test. It could be positive or it could be negative, right? So if it's positive, you're dealing with autoimmune hemolytic anemia, which could either be a warm one or a cold one. So how do you differentiate those two? Then you have a look at the blood film, right? And in the blood film, if you see agglutination of red blood cells, agglutination, that is a cold autoimmune hemolytic anemia. And why do you see agglutination? Because cold ones are mediated by IgM, and those are large molecules, so they hold multiple red blood cells, they come together and they cause the agglutination. And if you see spherocytes, you're dealing with a warm one. So how do you get spherocytes in the warm ones? Because warm ones are mediated by IgG. So IgG coats the red blood cells, and the red blood cells are going through the reticular endothelial system. They remove parts of the membrane which are coated by the IgG. So they lose the surface area and they become spherocytes ultimately. All right. And the two other things that are suggestive of cold or warm ones is that when you do the antibody test itself, in the cold ones it would be only C3 that would become positive, and the warm one could be IgG plus or minus the C3. All right, so that was very easy and straightforward. There is a hemolytic anemia. You do the antibody test, it's positive, so you know it's autoimmune. Then you have a look at the blood film. If there's agglutination, that's going to be a cold one. And then if there's spherocytes, it's going to be a warm one. Additionally, C3 only for the cold ones, C3 plus IgG plus or minus, IgG plus or minus C3 for the warm ones. All right, and the fun part comes when the DAT is negative. So what happens if the DAT is negative? It could be anything else that's causing hemolysis, right? Again, what you do is you examine the blood film. So blood film is the money shot. All right. So when you examine the blood film, what are the possibilities? You can see bite and blister cells. If you see bite and blister cells, that is your G6PD deficiency. So how does it happens in G6PD? Because of the G6PD, there's more oxidative stress inside the red blood cells. So this will denature the hemoglobins and cause Heinz bodies and stuff. So when these red blood cells are going through the reticular endothelial system, the cells in the reticular endothelial system tries to bite off or remove that Heinz bodies or the denatured hemoglobins from the cells and then giving the appearance to the bite and blister cells. Of course, this could be confirmed by the enzyme assay to confirm the G6PD deficiency. All right. And then what else can you see? You can see fragments, or what we call schistocytes or helmet cells. So what is this? If you see fragments of cells, you know that you're dealing with your MAHA, that is microangiopathic hemolytic anemias. What does this mean? In the blood vessel, there's a clot happening, and your red blood cell try to pass through this, and because of the sheer mechanical stress, the cell will break down, so there would be fragments and all. So where will you see this? You will see this in your hemolytic uremic syndromes, your TTPs, your DICs, and even the fragments could be seen if you're hemolyzing because of a mechanical heart valve or something. Right? So how do you differentiate the HUS, TTP, and DIC? It's mostly clinically. There's a classic pentad for TTPs, and for HUS, it's primarily, probably after an infection and a very significant AKI. And there are some tests as well, but mostly clinically. All right, so that is if you see fragments in the blood film. And the third one is that if you see spirocytes again. All right, so we talked about spirocytes if the antibody is positive. So now you are seeing spirocytes when the DAT test is negative. So that is your hereditary spirocytosis, right? And how do you diagnose it? Officially, you could do the osmotic fragility test, or you could do the new one is the EMA test. And also it is worth to note at times PNH could give rise to spirocytes as well. So yeah, this was a very simple diagnostic workup of hemolytic anemias. So firstly, we talked about what are the investigations that are suggestive of hemolytic anemias: low hemoglobin levels, increased red count, increased product of red blood cell breakdown, that is going to be your indirect bilirubins, and increased LDH, and the haptoglobin levels would be less because they're carrying the heme particles around. And then you directly go into the DAT test, antibody test. If it's positive, it's going to be autoimmune. Then you examine the blood flame. If there's spirocytes, it's warm. If there is agglutination of cells, that's the cold ones. Cold ones are IgM, and then the warm ones are IgG. If it's negative, then again you do the blood flame. If you see bite and blister cells, that's your G6PDs. I explain how it happens in the oxidative stress, hemoglobin denatured, reticular endothelial system try to remove it by biting those parts off, so you get the bite and blister cells. And if there's fragments or schistocytes or helmet cells, now that's going to be your microangiopathic hemolytic anemias, because the red blood cells break down because of sheer stress when they're passing through these narrow paths. It could be your hemolytic uremic syndrome, your TTP, or DICs. And then if you see spirocytes and the DAT is negative, it's going to be your hereditary spirocytosis. Could also be PNH. Just remember that. And then to diagnose the hereditary spirocytosis, things would be the EMA test or the osmotic fragility test. So those are common causes or the common classification of hemolytic anemias. But this being said, this is just like an approach to it, and there are other things that can cause hemolysis as well. It could be a transfusion reaction, it could be a drug-induced one, it could be due to malaria. There are so many things, but this is a simple workup, so you can get the ball rolling and process. But there are so many other causes that can give rise to hemolysis as well. So yeah, that's about it. Hemolytic anemias done.